When arriving in Milan, one must certainly ask themselves how a major, ancient city like this developed seemingly without access to any major river or body of water. Milan, one of the largest metropolises in Italy, seems to have none of it. Surprising, given its nickname, the City of Water. So, let's look at its origins. Even though Milan is situated in the Po River basin, no major river runs through the city. Looking just at the map does not answer why it developed into a core of a water-hungry metropolis. A transect on a territorial scale is needed to understand Milan's peculiar situation. On the 100-kilometer-long section ranging from the Alpine Lake Como to River Po lies the answer to the mystery. Following the descending terrain and underlying soil layers, we learn that Milan was located exactly in the median zone between the high and low plains, where the impermeable layers of the soil push the underground water to a level where it almost reaches the surface, thus making the water in the area abundant and easily accessible. The natural water system is composed of rivers that connect the lakes and Po River and of many seasonal torrents. The north-south running rivers were complemented by perpendicular artificial canals, called navili, that together create an elaborate water system which gave Milan its identity. On the historical maps we clearly see the importance of water. Milan's canals served as transportation routes and fortification systems. Unfortunately, later they gave way to the mounting pressures from the automobile and the road system. Open waters were canalized and Milan's connection to water became increasingly unclear. The water has disappeared. Milan, once known as a city of water, will soon be challenged by the ecological issues related to climate change. This launched our investigation on how the situation can be remedied and the metropolitan landscape made greener, more livable, and more resilient. We focused on 3 intervention areas and their corresponding strategies, which encompass 3 distinct landscapes that follow the path the water takes, north to south, in the metropolitan area: the Alpine foothill, the suburban belt, and the agricultural fringe. Our concept considers the fragmentation of the area in order to propose 3 specific actions on 3 specific areas through the north-south axis. Along the natural river, the first challenge is to supply and slow down the water in an area that experiences major water level variations. Then, in the area just before the city, a buffer zone needs to be designed to connect the city with water and prevent future extreme climatic events. Finally, following the city proper, a filter zone will act as an urban growth boundary while purifying the urban runoff. A. Supply. Square A is located at the junction between intermittent torrents coming from the mountains and the valley, where the river is inaccessible. Our strategy is to use the slopes of the topography to create a collector. Then we reopen the previously hidden river and connect some parts of it to create a continuous system. 2 sides of the collector have different slopes and therefore different roles and issues. The north one is to slow down the water coming from the mountains. The south one has an objective to clean the polluted water coming from the urban area. For slowing the river in the north, we create swimming pools integrated into the landscape. For cleaning the water in the south, we create 3 types of basins which successively collect, purify and stabilize the water before it reaches the collector. This intervention has an additional benefit of giving residents access to water for recreation. B. Buffer. The strategic location of Square B has 2 main characteristics. The first one is the river passing its part, and the second one is the system of irrigation canals. The division of the area between industry, residential and agriculture allowed us to separate permeable surfaces from hardscape. Using this data, we utilize the roofs of industrial buildings to create a range of interventions that take the water from the large impermeable surfaces and restore them for agricultural use. Nowadays, the river passing through the area is not being actively used. For this reason, we decided to create major open spaces that attract inhabitants to the water. Water infiltration is one of the most important actions that all cities should do to minimize floods and distribute the water. That's why we introduced more than 10 new locations where we will use bioswales in order to absorb and filter the water. These strips will transform the overall appearance of this area from a hard landscape that canalizes water to one that lets the water infiltrate freely. we will be able to provide citizens with a greener and more vibrant city. C. Filter. The Square C is located on a border between highly urbanized city of Milan and the farmlands. The city and the fields are separated by an arbitrary border without physical separation or transition zones. Existing water system consists of rivers, canals which resurface in this area, and a piped sewage and stormwater system. We propose to make use of the urban runoff by diverting it towards the agriculture, but the polluted water must be treated first. This is done by constructed wetlands on the urban growth boundary. Constructed wetlands filter polluted water through feet of purification. Their area and design is based on the flow rate and level of pollution. Paths and footbridges connect wetlands to the city, giving inhabitants access to the water and recreation, while at the same time reinforcing the urban growth boundary. This transition area supplies the agriculture while reintroducing the social aspect of water. Collectively, our interventions create a complete water strategy for Milan. They also have a potential to scale up to other locations, together creating a backbone of a metropolitan park. Our interventions will prepare Milan for the climatic challenges of the future while reinstating its rich water heritage and allowing the water to become once again a part of its identity. So, let the water flow. Thank you.